No. Yeah? Testing one. Whoa. Okay. Cool. And don't you forget it. You said he's got the power. Okay. We've got lots of those today. Hello, my name's Mark Lenigan, and the title of my talk is Community Wireless Networking. I've been involved in community wireless networking since the late part of September 2001 when I joined the Champaign-Urbana Community Wireless Networking Initiative. And from 2000 and late 2003 to 2004, I was involved with the Detroit Wireless Project in Detroit. No, I'm actually using that actually. We're going low tech today. Yeah. We still good? We're rolling? Okay, good. So anyway, I should start off by saying what is a community wireless network, because the definition I tend to use is a bit different from what you're typically going to hear. I'll differentiate between a community network and a municipal network. And a community network is one that's a grassroots, usually a nonprofit group. It may have a for-profit element, but I don't know of any of those, honestly. And the purpose of this network is to directly benefit the members of the community that it serves. That if they believe that they need greater internet access to bridge the digital divide, to provide educational services to far-flung regions, like for example, there are Indian tribes in Southern California that use community wireless networking software and routers to link disparate reservations together so that they can maintain their cultural identity and provide the education they want to their children. And it will serve the community's unique networking and communication needs. In contrast, a municipal network usually involves the municipal government and typically gets into the same sorts of problems and pitfalls that cable TV companies and concessions get into, that the municipality will pick one company to design and install and build the network, and then essentially they will gain a natural monopoly on this service and be in exactly the same situation as you are the cable TV companies or ILEC telcos and things like that. And basically, the reason for wanting to start a community network is to get around these things. I first got involved in this because where I lived in Urbana, I called up SBC, which was my ILEC at the time, and I told them I really wanted to get a DSL connection so that I could run my own servers and learn more about networking and that sort of thing. And they said, great, we'll pre-qualify you. Okay. The pre-qual says I'm 11 or 12 feet too far away, which isn't surprising because I was about 300 yards beyond Urbana city limits, and like the next thing over was a freeway, and after that was a cornfield. So I was a little put out, but I could understand. But then that really meant that my only two other options for internet service were dial-up internet, which at that distance I was getting an awesome 300 baud. And because my phone lines were probably installed sometime in the 1930s. And cable internet, which has a very restrictive acceptable use policy. So when I heard that there was this group forming in Urbana to bring connectivity via wireless, I jumped on board and helped as I could. And we'll get into the history of the wireless networking movement, community wireless networking movement. Usually they'll start up in the same sorts of situations as the old Freenets, if anyone's familiar with them. I mean, Cleveland did have one for some years. Detroit had one. I know there were other communities around that had that. And they tend to want to provide the same sorts of benefits, that when you have local people getting together, you enhance the they're talking about issues that are important to the community. Or you can even just use it as a social organizational tool that, hey, let's everybody meet at this restaurant at this time. And the initial efforts were slow and random because individual people were just saying, hey, I've got this access point or this computer with a wireless connection, I could share it with my neighbors, or there's this other guy that's 11 feet too far away to get DSL, we can set up a point-to-point to him. And there really wasn't too much thought of how far you could go with this. But starting in about late 2000, maybe early 2001, several different efforts got started in various cities that were looking at wider issues of how far you could push this technology. Probably the most famous is Seattle Wireless, which you can find at seattlewireless.net. And they started with long-range point-to-point links across Puget Sound, access points set up in the neighborhoods, and a very, very ambitious and, in my opinion, overly thought-out network topology that they had like 4 different types of routers based on capability and that sort of thing. Also, there was Austin Wireless, which was a hotspot type of all they were doing was setting up hotspots because that's what they decided they needed, was more public places where people could access the internet. And NYC Wireless, who mainly deals in providing wireless internet access to low-income apartment buildings, as far as I can tell. They also work in hotspots, but from the people I've talked to at NYC Wireless, that's what they were working on. And then there was CU Wireless, which looked at how can we build a box that, a router really, that someone with very little technical knowledge could install this on the roof of their home, power it up, and it just works and connects to the internet. The basic system for the CU Wireless router is you've got, if this is your house, you want to have the router as close to the roof line as possible, and it'll be mounted up there. It's got an 8 dBi antenna, and then from the side of the router, you'll have a weatherproof Ethernet cable that goes down into the house, and that's the DMARC right there. And from there, they can attach what they want, whether it's another wireless router, an access point. Thank you. Thank you. And, et cetera. And so, so basically, it allows, and what this allows you to do is that as the let's see here. As you said, if these are the coverage areas, and this is the city here, as you set up nodes with various coverage that overlaps, and if some of those are connected out to the internet, you gradually, with these self-organizing nodes, because when they power up, they compute their own IP address off of their Mac from a CD image of NetBSD on compact flash. I'm sorry, it's an image of NetBSD on compact flash. And then they compute their own IP address and immediately go into a search mode to see if there are other routers within their range. And if they find them, then they build a routing table from that using the hazy sighted link state algorithm, which was originally developed for the military for highly dynamic network topologies, like when you have things like Humvees and Apaches constantly on the move. So then basically what this allows people to do is just set this up, and as far as they're concerned, it just works. However, that's not really where we started. We first started, made a lot of mistakes. The first system that we started playing around with were Orinoco cards and the infamous or famous, depending on how you look at it, Pringles can antennas. They don't stand up too well to an Illinois thunderstorm. There's a picture on an NCSA website, which I couldn't find before the talk, unfortunately, of one that looks like it had been hit by a truck. But all that had happened was it was rained on. And we also initially started with scrounging PCs, which incidentally was what you saw me working on in the knock earlier in the weekend, and with the similar results that turns out PC hardware is not really what you want to build a router on. It's very unreliable, but it's cheap and readily available. The other thing you can use are things like the WRT54G with custom software, but again, they're only marginally more reliable than PC class hardware. And from my experiences of installing stuff like this in plenum spaces that's not ruggedized, they tend to have a lifespan of about 8 months to 12 months before you have to replace it. What you really want are things like the Socrest 4521 or similar ruggedized routers that you can put in, that ruggedized waterproof enclosures are made for, and they'll stand up to anything. The unfortunate thing is because they're so well made and usually made in small lots, they tend to cost several $100s each, which means that you're going to be able to deploy only a few routers per, fewer routers per the amount of money that you're going to have. Usually, to start out with, the best way to start out if you're going to build a network is to pick a region of town where you have, that it's geographically compact, that you can cover it with maybe 4, maybe 12 routers, that they can all talk to one another, similar to this. And then you want 1 or 2 connections to the internet. This will, and once you get this going and can prove that you know what you're doing, then you can go out and pushing companies in the area, or perhaps agencies that will grant you money, that sort of thing, and start seeking more funding, because once they're relatively unwilling to trust just anyone, but if you demonstrate just even a little bit of clue, then there's many, many more people who are willing to help out. You'll find that people will be willing to, people in the community will be willing to donate all sorts of things, even up to servers, co-location space, sometimes office space, money so that you can file 5013C paperwork, all that good stuff. And so with that covered, why would you want to do community wireless? The usual reason initially is underserved communities, which doesn't necessarily mean low-income communities. In Michigan, where I live, there are middle-class communities that, residential, or what am I thinking of? Subdivisions here that clearly would be in the target market of DSL, but for some reason the telcos aren't there, and in some cases the cable companies aren't there either. But they're a market for the internet, and this is that when the FCC does its survey of where broadband is available in the U.S., they do it by zip code. And if only a portion of that zip code, if one household in that zip code has access to cable or DSL broadband, according to their database, that area is served. And it doesn't matter that if, across town, across a major road, the other side of the tracks, there's no coverage. Oh well, there's some coverage, and therefore that counts enough for the FCC. And why I'm so up on DSL is that typically you can get DSL with fewer restrictions to run servers, to be an active participant in the internet, rather than the way the cable companies typically want you to use their residential connections, which is that it's just a big pipe. You can download stuff. They don't want to see you run servers. They don't want the problems of, the potential security problems you're going to cause